Internets. We're going to do a problem here. We're going to do a projectile problem, a problem about things being shot through the air. The problem I'm going to do first is we're going to pretend that we have a marble, and this marble is shot at 37 degrees. Okay, so it's going to be pretty steep, and it's shot at an initial velocity of 7 meters per second. That's what it's doing when it comes out of the marble shooter, okay? Now, one thing we have to understand is this thing is also going to land. So we go ahead and we finish a triangle like that, and we sort of make ourselves a nice big space to work with. Now, one thing we know here is this vector right here has a certain acceleration towards the Earth that is gravity. So we know the acceleration straight down towards the Earth on this vector is going to be 9.8 meters per second every second, because we're on Earth, that's gravity. And another thing we know is we've broken this thing up into sets of triangles, okay? We can trig our way around to find an initial velocity here and an initial velocity here. One of the things we need to understand is the initial velocity on this axis is only an initial velocity. The velocity on this axis will remain the same constantly. So let's try some stuff out. A marble launcher shoots a marble at 70 meters per second at an angle of 37 degrees. How far will it go? How long will it be in the air? And how high will it go? Well, if we look at the information we're given, the first thing we honestly can find out is we can find this velocity right here through using trig. We know this angle, this side is opposite, this is the hypotenuse. So I would say to find this, I would say the sine of 37 degrees, that's our angle, is equal to the opposite side, that's this velocity right here, over the hypotenuse, which we know is 7. So I'll just put a little there for opposite, okay? To solve for the opposite side, 7 will come up here. 7 times the sine of 37 will give us the opposite side. So let's see what that is. We'll give them a calculator. I'm using one of these bad boys, a real simple TI-30. 37 sine times 7. That gives us an initial velocity up of 4.21 meters per second. Now, it's a good idea to go ahead and keep a couple decimals, because we're going to use the number later. Okay, we're going to use this number again. So don't write 4.2. Go ahead and write 4.21 as your answer. That's going to help you out later. Okay, if something is going to go up at a velocity, initial velocity of 4.21 meters per second, it's going to go up, and then it's going to stop here, and then it would fall back down. And you may be saying, what do you mean up? Well, this thing's moving sideways. So check this out. If this one's moving sideways at 7 meters per second, and this one is moving up at 4.21 meters per second, then they're going to get here at the same time. Okay? Another thing you need to know is that the marble will go up and then down. So however long it takes this marble to go up, it's going to take that long to fall back down. So the total time that this thing will be in the air will be twice the time it takes this marble to go up and then stop. What rate is it going to stop at? 9.8 meters per second squared. So there's a real simple formula to use right here. The very simple formula we can use right here on this axis, since this axis right here, remember, is affected by gravity, we can say the acceleration on this axis is equal to the change in velocity over time. The acceleration on this axis is 9.8 meters per second squared. The change in velocity will be from 4.21 to 0. So we can just put 4.21 in here. And now we're going to solve for this time. We can switch those two numbers. We're using algebra 1 here. T is equal to 4.21 over 9.8. that gives us a time of 0.43 seconds for it to go up. Well, guess what? It's going to fall back down as well. So the total time in the air is equal to 0.86 seconds. Because remember, this thing will go up and down. This thing will go up and down. So the total flight time is 0.86 seconds. All right, let's figure out how high will this thing go? Well, it's the same thing as saying if you dropped a marble and you dropped it starting at 0 and you dropped it and it fell for 0.86 seconds, how far would it go? That's going to be the same answer whether you pretend this thing's going up and stopping or going 0 and then falling. The formula that we can use for acceleration and distance is xf is equal to 1/2 at squared. And we know from our physics unit that this is actually the shortened version of this longer formula, VIT, plus 1/2 at squared, but none of these numbers mean anything to us right now. So the short version that you need to know, if you're dropping something or shooting it up, xf equals 1/2 at squared. All right, how long will it take this thing to drop? 0.43 seconds is how long it will take it to drop. What is A? 9.8. 1/2 of 9.8 times 0.43 squared. Let's try that really quick. That gives us 0.9 meters. That gives us a total distance of 0.9 meters. 0.9 meters, that's how high it will go. Now, let's see where it's going to land over here. Let's see where it's going to land. That's easy. Remember, the velocity sideways is going to be constant. And I know you may be asking yourself, why is that? If this thing's going up and slowing down, and this thing's going up and slowing down, why isn't this slowing down? Well, the thing is, this is like a shadow moving across the earth. If you shoot a marble and it goes up and down, the shadow moving across the earth will move at a constant velocity. So whatever your initial velocity is here sideways, it will remain the same for the entire 0.86 seconds of flight. Remember, 0.43 is your up time, but 0.86 is the time it goes up and down. That's the total flight time. So let's find this velocity on that leg of the triangle. We've got 37, a 7. I know, we'll try cosine. The cosine of 37 is equal to the adjacent side, that's this V, over the hypotenuse, which is 7. So cosine 37 equals adjacent over 7. Once again, we're going to take the 7 and put it up here using Algebra 1. And we're going to say 7 times the cosine of 37 will be the velocity on this side of the triangle. So I'm going to say 37 cosine times 7 equals, it's going to give me 5.59 meters per second on this leg of the triangle. It will move sideways at 5.59 meters per second. It will be allowed to do that. 4.86 seconds. And then that'll be our distance. 5 times 0.86 equals 4.8 meters. So if you shoot a marble at 7 meters per second and 37 degrees, it will fly up in the air. It will take it 0.43 seconds to get up there. It will take it 0.43 seconds to get back. It will land 4.8 meters away. It will achieve a total height of 0.9 meters, a total flight time of 0.86 seconds. And it will be, its shadow will be moving sideways across the earth at 5.59 meters per second. And I hope that you like that. All right.